already know can also be called inert gas. It can also be called real gas, and it can also be called unreactive elements. All right. I think I've talked plenty this morning,
Yes, sir.
and all these things are questions that we don't know, but we have the answers already. We may not know the question, but you are having the answers already. So please, I know I'm taking the patience to explain these things. So when we start the chemical bonding, you don't need to be bothered with the example. Is calcium carbonate? What type of bonding? Is carbon dioxide? What you'll be wondering. You don't need to. Once you understand all these concepts, after this now I teach you about polarity, electronegativity, they will now come back to types of chemical bonding with an example. You can't be confused again. Which of these compounds is polar? Which of these compounds is not polar? Which of these can dissolve in water? Which cannot dissolve in water? They are all the principles of the bonding. The way they take man each other determines their chemical properties. So you have nothing to worry about, even the physical properties too. I'll guide you by God's grace. By God's grace. Okay, so we have said so much. Now let's still say more. Now, come back to this part of the board. For electronic configuration of atomic shells, a formula was given by Niels Bohr in order for us to get the maximum electrons on each shell. Please, in case you are not clear with it, let me just do one. N is the L shell, so you understand what I'm talking about. N equals to 2, that's the number 2 shell. Use this formula, my brother and sister. 2n squared. We should know small mass, abi? This will be 2, open brackets. N is what now? 2 raised to power 2. This is 2. 2 raised to power 2 is what now? 4. 2 times 4, 8. You do that for the rest. You get the idea?
Yes, sir.
Alright. Now, for atomic orbitals, to know the amount of electrons that each sub-level can accommodate, there's no formula, but there's a rule. Please, are we listening?
Yes, sir.
Here, there's a formula to know the maximum electron, but here there's a rule. A rule means law. Somebody gave us a law we must obey. So you must obey that law to know how many electrons that you can fill up in s orbital, p orbital, d orbital, and f. Maximum electron you can fill up. Before we now go to the pattern of filling, are you getting the scope now?
Yes, sir.
We must know the maximum before the pattern. All right. Now let's write. According to Hund's rule, Hund's, let me spell. According to Hund's rule of maximum multiplicity. You're not writing, sir. According to Hund's rule of maximum multiplicity, Hund's rule of maximum multiplicity, it states that electrons go into degenerate orbitals. Electrons go into degenerate orbitals of sublevels. Degenerate orbitals of sublevels. Electrons go into degenerate orbitals of sublevels singly. They must enter unpaired first. Hope I get it language.
Yes,
unpaired means single. So you must start with unpairing them singly before pairing. Enter into the orbital singly before pairing commences. Before pairing commences. Full stop. This rule is important. This rule is important in determining before pairing commences. Full stop. We have no feeling of single and pairing now. Pairing means you want to make them double. Alright. So before you make it double, sir, this guy say you must make it was a single. Alright. Now, this rule is important in determining the number of unpaired electrons. The number of unpaired electrons. This rule is important in determining the number of unpaired electrons of an atom. Number of unpaired electrons of an atom and the magnetic property of the element. Unpaired electrons and magnetic property of the element. Magnetic property of the element. Magnetic property of the element. Full stop. Alright. Very interesting. Don't follow me like that. Now, listen carefully. Let's come back to the story. Let's go back to the story. I believe even if today is your first time, there's no way at the end of this class you'll not be convinced that this knowledge has been made very simplified. I'm not rushing it. I'm not rushing it. We are focusing on how do we know how many electrons each atomic orbitals can accommodate. Since there is no formula, there must be a rule. Understanding those rules, then application of the rule will give us how many electrons each orbitals can accommodate. And the first rule I have stated just told us if you want to fill electron into these orbitals, you must start filling them singly before you pair. Now another person gave a rule how many each orbital must accommodate. I've tried saying something like that here. That if you want to pair, the maximum must be how many, sir? 2. Please, I watch the board. Yeah. If any orbital must be paired, maximum should be how many, sir? 2. Somebody stated that rule and you must know it. Let's write. Pauli exclusion principle. Pauli exclusion principle. That's the guy. Pauli, P-A-U-L-I. Exclusion. Look at the English. Pauli exclusion principle. Pauli exclusion principle. No two electrons states that no two electrons in an atom, no two electrons in an atom can have the same set of the 4 quantum numbers. No two electrons in an atom can have the same set of the 4 quantum numbers. No two electrons in an atom can have the same set of the 4 quantum numbers. Let's open the bracket. There's a symbol for representing the quantum numbers. There are 4 of them. I'm sorry I didn't start with that because the topic I'm teaching is chemical bonding. I just have to borrow the knowledge from quantum numbers. The 4 quantum numbers, these are the symbols. I'll tell you the name for the sake of knowledge. Then you can read up for me. We have N, which represents principal quantum number. This N is used for K element shell. You remember now? Yeah. K element shell, atomic shell, we use N. Then we have L, small letter L. This one represents azimuthal, or we call it subsidiary quantum number. Azimuthal is spelled A-Z-I-M-U-T-H-A-L. N represents principal quantum number, principal. L represents azimuthal. Another name for azimuthal is called subsidiary, or you call it secondary. Then we have ML like this. This one is magnetic quantum number. Then we have MS. This one represents spin quantum number. So there are 4 quantum numbers. ML, MS, spin, S-P-I-N. David, right?
Yes, sir.
Okay. Spin quantum number. ML, magnetic. L, azimuthal. Please, I've seen a question where they ask for the name of the symbol. I have seen. There are some questions that may seem useless, but you'll be the only one that have the idea. Because not every student pays attention to chemistry the way we do here. And not even every teacher pays attention to some of these things that these students should be them. And that's why I'm being very careful in every of my teaching. Every symbol, every dot, every tease, I make sure I tell us what it represents for the sake of higher knowledge. The small letter L. In fact, writing small letter L should not be curved. Should not be like this, so it should not be like this. Should not be like this, no matter how you're writing. Please, very, very careful. Ordinary pH failed me in 300 level. I didn't know it was supposed to be like this. The right pH and the lecturer failed and answer correct. Just cycle the places where I put pH. She do say now for just the equals to. You don't say when you don't have pH, now one I will not fail. I know the right pH just to make my work. The time they say pH, they go back me. They go. And stand up saying our tests. See, when you fail, don't see yourself as failure. You rejoice. Say, thank God I don't know my mistake now. And they tell you, that's just my secret. If I fail for tests or assignments, you are happy. See, well, no be exam. I will go channel all the energy, focus on exam. It has happened before too in calculus. I failed. They did not see my script, so not like I failed. But you know, I had to admit it. Once it's missing scripts, you are failed. But now I just put all that 0. Something I know I submitted, I know I did well. 30 marks in tests. My name was on orders 0. And test is 30 marks. Exam 70. Results come out. I scored 98 for exam. Person wey no know go think say na my efforts, no. But once you are intelligent, it's an advantage. Even if you score 40, when others are scoring 10. And you are plenty in your department, the lecturer might not have that time to want to give everybody carry over to come and add to the hundreds of students coming in for the next batch. What will you do? You start giving marks across board. So you first give everybody 10 randomly. You that score 40, you want to become 50. Somebody that scored 10 and gotten 20 and 20 still fail. You dash other people again 20 randomly, you want to become 70. That one has become 30 now, I mean 40 now, 40 from 10, 20, I mean 40 now. Then some people may score 5. After adding 10, adding 20, you are still fail, because 40 still fail in university. You add another 10 again, you want to become 80. You understand the logic now? So that's what happened. And as you keep adding, now ended up with 98. Since I did not see my test, but I know what I did in the exam, of which I can't get 98 over 70, it's not possible. Yes. And I was close to this lecture, so when he said it, I was like, wow. But I was wondering, how come? I don't want to go and do testimony without knowing the physical implication first, how God did it physically, before spiritually. For some of you just go and thank God, thank God they said I wrote rubbish. And when you talk about going one, you don't know the physical implications. But it's good to say thank God. Where at least there are some idiots you are better than in the department. If everybody passes, you know the streets. Someone say, so that we when the book small, our results go high. But I can't pray for somebody to fail. But if you happen to say, alright, let's continue.